All right, everyone. Let's get started. Sorry for the lateness of time, but I just got caught up in something. All right. So today's assignment is chapter 5.1. So homework 5.1. This is the second day. So part two. This is on page 346, 346, and you guys are gonna do numbers 69, 70, 71, and 72. Okay, and keep in mind we already did 72 in class, so 72 we're not going to do in this video, but it is still required to be on your assignment. So we will start with 69. Right? Rewrite the expression so that it is not in fractional form. Okay, so we're talking about sine squared y over 1 minus cosine y. Right? So to begin, we will need to rationalize this thing, multiply it by 1 plus cosine y. Remember, we want the conjugate of this, which is just, so the only difference is that it's just instead of a minus, we're going to use a plus in between. Okay, we're not going to do the opposite in the front. We're just doing in between, we're going to do the opposite. And if we do it to the bottom, we're going to do it to the top. Right? Excuse me. So with the top, right, you'd either distribute or you do an area model, just like this, with 1 plus cosine y, and then the sine squared y on the side. So by doing that, you will get 1 times sine squared y, it's just a sine squared y, and cosine y times sine squared y is you can do either one first, but I'm going to put the sine first. So you get a sine squared y cosine y. All right, so that's what I get on top. Yes, sine squared y plus sine squared y cosine y. Okay, and that's multiplication. All right, on the bottom, this will be another area model, but this one's going to be a little bigger because there's two terms. Right, so we will have a 1 plus cosine y and a 1 minus cosine y. Okay, doing the math, we get 1 times 1 is 1. 1 times cosine y is a cosine y. 1 times negative cosine y is a negative cosine y. And negative cosine y times positive cosine y is a negative cosine squared y. Okay, you notice these two are going to cancel out, and we will be left with 1 minus cosine squared y. Okay? Now that 1 minus cosine squared y, that is related to this trig identity, sine squared y plus cosine squared y equals 1. And if we want 1 minus cosine squared y, we would just have to move this cosine squared y to the other side. So we would have to do a minus cosine squared y and minus cosine squared y. Okay, and that's going to allow us to get a sine squared y equals 1 minus cosine squared y. Okay, and that's what we have right there. Okay, so 1 minus cosine squared y, 1 minus cosine squared y. We're going to substitute that with this right here. So instead of 1 minus cosine squared y, instead of 1 minus cosine square y, we can use sine square y. Okay, and on top it's still going to be sine square y plus sine square y cosine y. And where we can go from here is that we can now, in period 5, Josh Carr and them called it the loop-de-loop, right? But this right here over, or that right there, plus this right here. Okay, so nice naming, Josh Carr. Loop-de-loop, right? So by doing that loop-de-loop, we will have a sine square y over sine square y, and that's the first loop-de-loop. That is just doing that right there. Okay, the second one is plus sine square y cosine y over sine squared y. You might notice that these right here, these will simplify down to 1. Right, and these right here, these will actually simplify. You could cancel these like this, right? And all you have left is just this cosine y, or you can call this 1 times cosine y, okay? Which I'm just going to call cosine y. Okay, and that's your answer. 1 plus cosine y. Right, and remember, that's how we started with sine squared y over 1 minus cosine y. Yeah, imagine all of that work, and then we end up with 1 plus cosine y. Right? So that was number 69. 70. 5 over tangent x plus secant x. Okay. Again, we're going to use the same idea. We need to go ahead and do the conjugate of, which is tangent x minus secant x. And if I do it to the bottom, I have to do it to the top. Tangent x minus secant x. And remember, the reason why we can do this is because we are basically just multiplying this by a big fat 1. When multiplying by a big 1, it doesn't do anything. It doesn't change the value of this expression. It changes the look of it, okay, but it doesn't change the value of it. So therefore, we can actually multiply it by the same thing on top and on the bottom. Okay, by doing this. Okay, so I went and did the area model the first time around, but this time around, I'm going to expect you to do it. So if you don't want to see the answer just yet, do the area model. If you are okay with it, and if you've already done it, okay, go ahead and just play this out. If you want to wait and see what you get, pause this video right now. Okay, so on top, I will get 5 tangent x minus 5 secant x. On the bottom, again, do an area model. This is going to be a 2 by 2, and you have 4 things in the middle. You will end up with tangent squared x minus secant squared x. All right, and we're going to go ahead and we are going to use a trig identity. All right. Hopefully you can remember what's trig identity. All right, so you're going to use the trig identity. I'm going to put this in green. 1 plus tangent, or is that secant? 1 plus secant, or 1 plus tangent. Square x equals secant square x. Right, and if you're not sure, you can always check back through your notes. I'm going to look really quick just to make sure. trig identity or Pythagorean identity is 1 plus tangent square x equals secant square x. So this is the correct one. Right, and you can see now, how do I make this look? Right, how do I get this? How do I get this part? Right, how am I going to get this from over here? Right, so to get it, I think I need to take this secant square x and I need to move it back this way, and then I need to take this 1 and I need to move it that way. Right, so by doing that, I will get tangent square x, and then if I move the secant square x, I would subtract that, so it would be secant square x, and then equals, and then if I move that 1 over, it'd be equal to minus 1. So if you look at that, we now have tangent square x minus secant square x, and that's equal to 1, or excuse me, negative 1. Right, so with that being said, we have 5 tangent x minus 5 secant x over negative 1. Right, because remember, we're replacing that negative 1 with this right here, just like how we replace negative 1 with this right here. And with that, I can wrap it up and say, and again, we can do what period 5 is saying with the loop-de-loop, and we can take this and divide it by negative 1. Then we can take this and divide it by negative 1. All right. So with that, we can finally say the answer is going to be negative 5 tangent x plus 5 secant x. Ooh, and I know a better way to write this. Since this is positive and since this is negative, I'm going to write the 5 secant x in the front and then the minus 5 tangent x in the back, and that is your final answer. Okay, so we started with this and we ended up with that. Okay, that was number 70. If you need to, rewind, pause, whatever. Okay, and the last one, okay, 71. We've got 3 over secant x minus tangent x. Okay, so this looks very similar to the last one. The last one was tangent x plus secant x. Right? The last one was tangent x plus secant x. And this one is secant x minus tangent of x. Right, so same kind of idea. Right, so again, I'm going to go ahead and conjugate this or rationalize this using the conjugate of the bottom, which is going to be secant x plus tangent x, and then the top is going to be the same thing, secant x plus tangent x. Excuse me. Go ahead and do the area models or multiply it out, whatever it takes. If you need to, pause it while you work it out. Shouldn't be letting poor Mr. Cha doing all the work for you. Right? You'll get 3 secant x plus 3 tangent x. On the bottom, again, if you need to do the area model, pause this video while you work on it. Okay? If not, here's the answer. Secant square x minus tangent square x. All right? Again, this looks very similar to a trig identity. All right, again, we're going to use this trig identity right here. We are going to use the 1 plus tangent. So we're going to use 1 plus tangent square x equals secant square x. Right, and again, we need to have this right here. We need that. which is sort of over here if we just subtract the tangent over, right? So we're going to utilize this, but we're going to go ahead and we're going to go and take this tangent square x, this positive tangent square x, and we're going to move it over to that side. Okay, so we will get a trig identity of 1 equals secant square x minus tangent square x. Okay, and that is what we want, secant square x minus tangent square x, and that's equal to 1. So by doing this, we have swapped out the secant square x minus tangent square x with just a 1. Okay, on top we got 3 secant x plus 3 tangent x. See, you should have done it by yourself instead of just watching my video, because now I ruined it for you. Now I get to have all the fun and you just copy. If you did it by yourself, good job. Give yourself a pat on the back. Attaboy or attagirl. Right? Other than that, we're going to go ahead and do the loop-de-loop as coined by period 5, Jazz Carn Sing. Right there. So final answer, 3 secant x over 1 plus 3 tangent x over 1. And again, we because it's a 1, not again, but because it's a 1 underneath, we don't really need to write it. So I'm just going to go ahead and erase it. I was going to write it again, but you know what? I'm not feeling it, not feeling it right now. So I'm just going to go ahead and erase it. And that is your finale. That right there comes all the way from this right here, fraction. Okay, so that right there comes from that. All right, that is a wrap. Thank you for joining in on this session.